Ladies and gentlemen, welcome to video number 14 in a series of video lectures which are companions to the book The Fivefold Sun, encompassing 15 volumes over more than 6,000 pages. This book was filed in late 2017 at the Bibliothèque Nationale de France in Paris. We are today November 19th in the year 2018, about a year later. Today in this video we concentrate on the longitudinal evidence for or against icosahedral symmetry in the solar ball. In part 2 of the Fivefold Sun, we will now discuss sections 10, 11 and 12. The contents of video number 14 starts with a wrap-up of the suggested 12-ball 3D model for the solar ball and its longitudinal setup. We shall then ask ourselves if the observed latitudinal peaks in sunspot density, as introduced in video 13, correspond or not to any observed longitudinal sunspot clusters. Then we will introduce some of the accepted notions in this subject matter and then introduce the findings in the book The Fivefold Sun that pertain to longitudinal symmetry in the Sun. The suggested model in 3D for the solar ball with the fivefold symmetry includes in each hemisphere five balls in a planar ring, such as this. So we have such a ring for the North Hemisphere and such a ring for the South Hemisphere. It is necessary to obtain the mutual tangency of all 12 balls, which is called in geometry frustrated arrangement, in which all balls are mutually blocked in position, in this case around the central cavity. It is necessary to rotate the hemispheres, the 5 rings, by a certain angle. You see, if they are facing with no staggering, they are not all mutually tangential. This is achieved by this rotation, which is a 36-degree rotation. The 36-degree rotation involves the interpenetration of the 2 sets of hemispheric ring balls. Each of the 5 balls in each ring will pierce the equatorial plane, resulting in some sort of weak hemispheric coupling, as is the case for the solar ball. This is what remains from the northern hemisphere ball in a 5-ring above the equator, and this is what goes below the equator. The equator is now cutting through this ball by this amount, which is about 5 degrees of latitude. This setup results in a spacing of the vertices of an icosahedron at which are centered the centers of the 12 balls, a spacing of 36 degrees projected in the equatorial plane. Thus, there are 10 equispaced planes, equispaced centers of the circles projected onto the equatorial plane by these small spheres. We can now ask ourselves whether the alignments along a certain longitude that were found to be along a certain longitude that was predicted from the icosahedral model, as we shall now again repeat. Do they correspond to any observed longitudinal peaks or longitudinal clusters in observations of the Sun? The icosahedral model, introduced in the previous video as a wire model in 3D, with two faces showing as white surfaces in this case now, reveals that the two main peak densities in latitude, which are at 10.8 degrees in latitude, and the secondary peak at 20.9 degrees in latitude, they are predicted to be aligned along a certain longitudinal line, which is the line which passes parallel to the rotation axis through the vertex of each toroidal face. So there are 10 such longitudinal lines, because there are 10 toroidal vertices in the icosahedron. Per hemisphere, there are 5 such vertices and also 5 such longitudes. This is what is predicted according to the icosahedral model, which was found in the previous video to be consistent with the observations of the characteristic latitudes that were just cited, 10.8 degree and 20.9 degrees. But we do not know so far whether these predicted longitudinal lines correspond to any observed kind of longitudinal cluster that may exist in the observed solar ball. So this is what we are going now to investigate. We turn now to the accepted notions in the field of longitudinal studies of the solar ball. First of all, in the literature, there has always been a discussion of the presence of persistent longitudes. Cassini in 1688 first asserted that he saw sunspots returning to the same positions after decades. In the literature over the 19th and 20th century, these notions were called complexes of sunspots, or nests of sunspots, or clusters of sunspots, etc. The conclusions remain to this day unclear as to how persistent they are, but especially at which spacing, if any, they would recur, at which longitudinal spacing. Are they reappearing with a separation as a quadrant, 90-degree angle, as was suggested by some authors, or not, is one of the unsolved questions. Then there is in the literature the notion of giant solar cells, which are magnetic in nature. These were first suggested by Bumba and his collaborators in Czechoslovakia in 1969. Bumba, 1969, asserted an angular distribution of 35 degrees for such cells, which is very close to a decagonal distribution with a 36-degree angle as predicted by the icosahedral model. As for sunspots, there is no periodicity of 5.4 days, which is 1/5 of the solar rotation, which is stated in the literature. In the solar wind also there is no 5-sector structure whatsoever, and no odd sector number in fact is expected at all, because we have to have 2 magnetic polarities or a multiple of 2 i.e. 4 sectors, 6 sectors, possibly. So there is no trace, no clue of any pentagonal distribution in longitude of activity in the Sun or any other phenomenological parameter that would verify anything pentagonal, but perhaps a decagonal after the postulated distribution of giant cells in 1969. We now go into the findings in the book The Fivefold Sun, and we start with the notion of persistent longitudes, which is revisited in this project as a meta-analysis of published results since the beginning of this subject matter, which is earlier than the 19th century. The finding from this meta-analysis is that observed absolute longitudes for the peaks in sunspot distribution verify a separation of about 70 degrees. This is, in fact, separation into 4 to 5 peaks in odd cycles and 1 more peak in even cycles, 5 to 6 peaks. We also are able to make a census of the explicit mentions of absolute longitudinal locations for these active longitudes or complexes or nests of sunspots that remain persistent over many cycles, many decadal solar cycles. And we find that from this meta-analysis in in section 12.2.6, these locations are about 80 degrees, 120 degrees, 190 degrees, 260 degrees, and 310 degrees. These are 5 locations which are to be robustly determined, plus a 6th one which would be different in odd or in even cycles. So we have a characteristic angular separation for persistent longitudes which is close to a pentagonal one, close to 72 degrees, as opposed to the estimated distribution of giant magnetic cells, which would be decagonal. And perhaps we have to assume that the persistent longitudes are transhemispheric, which would reconcile the two findings. We don't know because in the literature, unfortunately, there is no distinction in the data sets and in the results between North and South Hemisphere. So we have to turn to other parameters, other concepts to try to sort out this problem. So we now turn to the notion of giant magnetic cells to look further into this longitudinal distribution. Again, the Fivefold Sun project included a meta-analysis of the results that could be found in the literature. And this is what was found, which is valid only at high activity epochs when there are the most numerous sunspots. First of all, the characteristic separation in the whole Sun for such giant cells might be exactly 36 degrees plus or minus 2 degrees, a central value which would be the decagonal one, and which is only a refinement of the finding of 35 degrees by Bumba in the original study in 1969. This would involve 10 cells for 2 hemispheres. Whether there are actually half as much in each hemisphere is not clear. What is found further is that there is a bimodal distribution in the size of cell surfaces, such as the bimodal distribution that was found for latitudinal distribution of sunspots in the previous video. Maybe the giant cells are transhemispheric totally or in part. So we are left to this point with the uncertainty, the undecidedness of whether the structures, sunspot complexes or clusters, etc., under investigation are transhemispheric, or if not, how they are distributed between the two hemispheres, because this parameter is not in the data sets that were reviewed in the literature. So we introduce a new approach in the Fivefold Sun project to elucidate this problem, which is to look at a series of daily hemispheric relative sunspot numbers. Because they are hemispheric, we have separately, of course, the counts for the north and for the south, and we will now be able, going from this primary statistic, to find what the periodicities implying a certain longitudinal distribution actually are. The result is that for high activity intervals, since 1946, we find a intra-rotation hemispheric period of 5.4 days. It is the same within error bars in the northern hemisphere and in the southern hemisphere. Whereas for the low activity intervals, it is double as much. It is 10 days, and when there are almost no sunspots, it is again double, about 20 days. So it seems that there is a floor for an intra-rotation period in the local maxima of the daily hemispheric sunspot number series. And this floor would be about 5.4 days, which is a fifth of the solar rotation. This implies a ceiling of 5 solar activity vertices per hemisphere. How is it possible, however, that we have 5 vertices in the Sun, each having concentration of sunspot and magnetic activity, and this is not found in the solar wind where there is no 5.4 day period or no 5-sector structure. This is possible if we find that there is an alternation of 4 and 6 magnetic sectors averaging out at 5 over a certain time interval. This is what is in fact found for sunspots themselves at the photospheric surface, but will not be discussed here today. We go directly now to the case of the magnetic sectors in the solar wind, and we find from the meta-analysis of this solar wind sector structure in solar physics literature that in fact, for example, in 1990, at this particular decadal maximum in solar activity, there was an alternating 4-sector and 6-sector structure which averaged out over the entire span of a few years of this sunspot maximum to 5 sectors. So when you look at a map of the sectors, it is never a 5-sector map, but over a certain time, when we are in a high activity epoch, this averages out seemingly at 5 sectors. So we would have in this case again a ceiling number of about 5 sectors as an average of several years of high activity in the Sun, which would be in the observations that could be assembled for this meta study. This is now the time to conclude on the longitudinal distribution of activity in the Sun. Indeed, persistent longitudes do exist in solar activity. This is not new, it's just confirmed. As for the absolute locations of these longitudes, they are not fully elucidated so far. This is also not new. What is now suggested here, and is valid only for high activity epochs, is that, first of all, for a time average of more than 1 year, there exist 5 activity, so to say, vertices in each hemisphere of the Sun, on average. In the whole Sun, there are twice as much, i.e. 10 such vertices, and we have to suppose that they must be staggered to arrive at a symmetric distribution. Secondly, in the shorter term, less than 1 year, during these high activity epochs, there is an alternation that is observed between 4 and 6 persistent sunspot longitudes, and also between 4 and 6 magnetic sectors in the solar wind. So all of these findings seem to be consistent with the 10 vertex longitudinal lines predicted by the suggested icosahedral model, which was shown again at the beginning of the present video. This is now the end of the discussion of the findings of part 2 in the book, The Fivefold Sun. This part 2 dealt with the solar ball's three-dimensional geometry. However, we will have more in part 6, seen from the point of view of the two-dimensional geometry of the Sun's surface, in which we will combine the findings of latitudinal positions and longitudinal positions as reported from individual sunspot sightings, as opposed as to so far discussed relative sunspot numbers, which are not physical sunspot numbers. This is, ladies and gentlemen, the end of video 14. I thank you for your attention.